Hello everyone. So today we are going to solve another very interesting and practical problem, number 135 from our coding series. And this problem is about distributing candies to the n number of children. And the problem is something like this. So we have been given one ratings array in which we have been given the rating of each child, and I don't know how their rating is mentioned, but they have been assigned some rating. So the rating is for children. So, and the childrens are present in the indexes from 0, 1, and up to n minus 1. And what we need to do is we need to satisfy these two requirements for each child when we are distributing the candies. So the first condition is that each child must receive at least one candy, and the child with higher rating get more candies than their neighbors, and the neighbor can be from both left and right. So so let's dive directly into the problem, and for that uh, we need to be over here. So the first condition, I think we can all agree, we can satisfy is just like this, that make one if I make one candies array and I assign one candy to each of the children, then I can just provide all my children with one candy. So my first candy condition is satisfied over here. And the next condition was like I need to give more candies to the children whose rating is higher than its neighbor. So for that, what we'll do is we'll just uh, look a quick scan from left to right and compare the rating, that if my current rating is greater than the previous rating. If it is true, then what I would do is I would just add 1 to my current child rating. So I will go over here, and the ratings was, I believe, Z1, 0, and 2, right? 1, 0, and 2. So that is the case. So in this case, I need to add 1 over here. So I'll do that with this. So to this child, uh, I'm comparing compare this child, I will need to move from 1. So after moving between these two, I'm seeing the next child has higher rating, so I will add 1 over here. So now the distribution will become 1, 1, and 2. Similarly, to satisfy the right condition, if I'm moving from to check for the other neighbor, I need to move from right to left. So then these two, the rating for this child is higher, and I've already given 1 to it, so I need to compare between these two child. And here I see the rating for the uh, current uh, rating is more than the previous, so I'm coming from this direction, and I is from uh, n minus 2 to 0. And so I will compare between these two current rating and the previous rating of my children that I'm going to compare. And if I again found yes, the current rating is higher than the previous rating, then I will again add 1 to my current child rating. So between 0 and 1 index child, I will see that the 0 index child has a higher rating, so I will add 1 to it. So this will become 2, 1, and 2. And in the end, I'll just do the sum of all the candies that I have to distribute. So that will give me the 5, and that is the answer that we are looking for, right? So now let's write this coding approach that we have understood. And so for that I need the first the length of the rating. And now what I'm going to do is I need to assign the candies to all the children that I will do. And as I'm moving from left to right, I will be starting from 1 because I need uh, at least 2 children to compare. So that's why I'm starting from I equals to 1. And if the rating of current rating is more than the previous ratings, so if I found this true, then what I will need to do is I will add 1 to my current candy uh, holding child. So that candy of I would be candies of r minus 1 plus 1. So, and similarly, I will do to satisfy this second condition, that if I'm moving from right to left, I need at least 2 children, so that's why n minus 2. And again, if the ratings of my current child is higher than the ratings of my previous child, so previous child in this case is I plus 1 because I'm coming from the right hand side. So I would look for the current. I need to look. I need to update my current child candies. So for that I need to compare it with the previous, and if I found it is greater, it is higher, the rating is higher, then yes, I need to add 1 to my previous child candies so that the current child will have uh, more candies than its neighbor. So this is the condition for that, and in the end, what we'll do is we'll sum of the all the candies array that we have maintained. So now let's run our solution and see how it performs for the different cases. So it has been accepted. So this is what the our dry run for the case 1, and let's submit our code for all the solutions. So it has been accepted and it's fast. And coming in terms of time complexity, so the time complexity is O of n, since we are uh, passing, since we are iterating through the whole ratings array, and since essentially we have created one candies array to distribute the candies among n children. The space complexity is also O of n. So that's the complexity analysis, and that's how you solve this problem. This problem algorithm is uh, the intuition was like we are following the simulation as defined in the problem, and which is typically considered as a greedy approach, that you are doing what is told in the problem and you are trying to acquire maximas as you are moving through in the problem. So that's how you solve this problem. And let me know if you have any particular problem in mind that you want me to solve, and I will have a look. Till then, be happy and be safe, and I will see you tomorrow with some new algorithmic problem. Thank you and have a nice day.